This is Lauren Zielinski, and I'm here to talk about monitoring and adaptive management in the Rufiji River Basin. In a previous lecture, we've discussed the foundation for creating a monitoring and adaptive management program, and now I'd like to present a case study to show how it can be implemented as part of an environmental flows effort. The Rufiji River Basin is located in central Tanzania, and at 177,000 square kilometers, it is the largest river basin in the country. It serves as the economic backbone of the region, providing resources for subsistence and commercial fisheries, irrigated and flood recession agriculture, water supply, and hydropower, among other uses. It also contains many protected areas, including national parks, game reserves, protected forests, and Ramsar sites. The Rufiji River Basin is broken up into four main subbasins: Great Ruaha, which is the largest subbasin by area; Kilombero, which contributes the greatest amount of flow; Luegu, which is mostly protected as part of the Salu Game Reserve; and Lower Rufiji, which is formed after the other three rivers come together. In 2016, an EFA was completed for the Kilombero subbasin using a modified building block methodology. The purpose of the EFA was to help guide the planning of expanded irrigated agriculture in the basin. As part of the implementation phase of this effort, a monitoring and adaptive management program is being developed and expanded to the entire Rufiji Basin. While the program is still under development, I'd like to share some of the details with you. We've talked about the three components of the monitoring and adaptive management program: developing management objectives, creating a monitoring plan, and implementing adaptive management. The same structure is being followed for this effort, but it has been slightly changed to adapt to different challenges and opportunities in the basin. First, the management objectives were determined. This was done through the development of a modified objectives hierarchy where different types of frameworks were analyzed to determine how this environmental flow effort would be managed. First, the legislative framework was reviewed. While there are many laws that touch upon environmental flows, the most important comes from the Water Resources Management Act of 2009, which defines the reserve as the quantity and quality of water that is required for basic human needs and protecting aquatic ecosystems. It also gives the authorization for the Ministry of Water and Irrigation to determine and implement the reserve. The second framework to be reviewed was regarding the management of the basin. An integrated water resources management and development plan for the Rufiji Basin was created in 2015. This contained a vision, objectives, and goals for the overall water resources management of the basin. The third framework was for environmental flows. In addition to the 2016 EFA, another EFA was completed in 2010 in the Great Ruaha subbasin, with the goal of restoring a sensitive wetland area and returning flow to a portion of the Great Ruaha River. These different frameworks provided the overall management objective of providing for the social needs of a growing population while also protecting aquatic ecosystems and providing for basic human needs. These management goals were then synthesized into the key ecosystem components for this basin. These key ecosystem components are social, water quantity for human and ecological needs, water quality for human and ecological needs, geomorphology, fish, macroinvertebrates, and vegetation. Once the key ecosystem components were selected, they were used as the foundation for developing the monitoring plan. Each key component needed to be narrowed in its scope to determine what should be monitored and how it should be measured. First, management objectives needed to be determined for each key component. Then specific indicators were needed to be selected, and finally monitoring methods were chosen. The official definitions from the Conservation Measures Partnership and examples of them are up on the screen. But in general, an objective is what you'd like to accomplish, an indicator is the data you'll track over time to see if you're meeting the objective, and the method is how you'll collect that data. There are usually many ways to monitor a single indicator, and they can vary widely in the collection time, cost, and complexity. We've come back to the multi-level system for our monitoring plan, where each level will help guide which monitoring method to use based on financial and staff resources available. This multi-level system was applied to each of the indicators for each key component, helping to focus the selection of the method depending on what data was desired. Once methods have been selected, then additional details can be added to the plan, such as trigger values, who will collect the data, location, timing, and frequency. One of the challenges of working in the basin is its size and remoteness. To try and cover the entire basin, the Rufiji Basin Water Board, the local management agency, operates over 50 river gauging stations. For this effort, that number was reduced down to about 20 priority river gauging stations, using the input of stakeholders and knowledge from the Rufiji Basin Water Board. In this way, limited resources could be focused on collecting data at those sites that will have the greatest impact for management decisions. In the monitoring plan, there is detailed information for each key component, objective, indicator, and method. I'll show you only some of the information available in the current draft plan, although some items are likely to change as the monitoring and adaptive management program is completed. This example is for water quantity or flow and is conducted for compliance monitoring. The purpose of this is to say whether or not reserve flows are being achieved. Pause the video and take a few minutes to read through the text. You'll notice that Level 1 monitoring is to be conducted on an ongoing basis by the public, Level 2 will be undertaken by the Rufiji Basin Water Board, and Level 3 will be completed by experts. Here's another example from the draft monitoring plan, this time for macroinvertebrates. This falls under the category of effectiveness monitoring, since we are trying to see how macroinvertebrate communities are responding to the implementation of the reserve. For this example, we took advantage of an opportunity already happening inside the basin. The Level 1 recommendation was to conduct a simplified macroinvertebrate monitoring method, and it was found that 2 other organizations were training local villages to conduct that same type of training for their own projects. To take advantage of combined resources, these efforts were incorporated into the monitoring plan with the approval of all stakeholders. The data collected as part of the monitoring plan will feed directly into the adaptive management cycle. One of the main ways this will be accomplished is through the use of trigger values. For each method, a trigger value will be determined. If the data collected surpasses this trigger value, then the evaluation process is started early. This allows for managers to become aware of a problem before conditions become too severe. While the adaptive management aspects of this project are still being finalized, I'd like to share some of the ideas that have been proposed. First, there is an effort to improve decision-making tools within the Rufiji Basin Water Board to help managers make informed decisions. These include installing a specialized data management and analysis program, developing a desktop reserve tool that can help make preliminary environmental flow recommendations based on modeled hydrological and ecological data, and creating a water allocation tool that will give information on the amount of water that has already been allocated through permits and what is required to stay in the river for the reserve. It's also important to have a set schedule to review and evaluate the data collected from the monitoring plan. It is being recommended that this occur on an annual basis and to have a report produced by the Rufiji Basin Water Board containing this information. There is also the possibility of creating a basin scorecard of the environmental quality for different parts of the basin to give to the public. And finally, it's been recommended to develop a multi-agency steering committee to review the data, evaluate if management objectives are being met, and what actions could be taken in the future. It's important that other agencies are involved in this process, since other types of management actions affect the river as well. The take-home message for this case study are to develop a monitoring and adaptive management program so that the steps are interconnected. The development of management objectives should drive the monitoring and adaptive management program. Be sure to understand the challenges and opportunities in a river basin so you can adjust your program to make sure it's implementable. And be sure to keep stakeholders involved in the process to find solutions to problems, including sharing resources and management responsibilities. That is the end of this case study. Thank you for your attention.